Breathing system. During this module, we will discuss the various components of the breathing system. The breathing system is a low-pressure system. All parts of the breathing system are exposed to every breath. This system is easy to access and break apart when necessary without any tools. However, it is very important to make sure that it is put back together without any leaks. The flow sensor module has 2 ports, and this is where the breathing circuit connects to the machine. The sensors tell the system how much gas is going to and from the patient. A transducer measures the pressure, but moisture can build up and affect the pressure readings. The breathing circuit module houses the oxygen sensor. Gases going to the patient pass the sensor, and it detects the percentage of oxygen that is delivered to the patient. This analyzer is the only monitor that will detect problems downstream from the flow control valves. The analyzer must be calibrated during the FDA machine checklist. To help reduce moisture in the breathing circuit module, a drain button is placed on the expiratory side. This button will permit moisture to go down into the absorber canisters and eventually into the drain dish. This button can be pushed during a case. The breathing circuit module can be changed during the case if necessary. Unidirectional valves are used in the circle system. As gas flows forward, the disc is pushed upward. This allows gases to flow toward the patient for inspiration and away from the patient for expiration. During inspiration, the expiration valve is closed to avoid rebreathing of CO2 and exhaled gases. The inspiratory valve closes during expiration to avoid mixing of exhaled gas with fresh gas. There are 2 clear domes that are visible with thin, light discs that will flutter when the gas is passing through it. The discs are important to watch because they can malfunction, causing hypercapnia from rebreathing. The control panel has the bag ventilator switch. This allows the anesthesia provider to choose between manual, spontaneous breathing or machine ventilation by flipping the switch. The APL valve, or adjustable pressure limit, releases gases to atmosphere or to the scavenging system, and its purpose is to provide control of the pressure in the breathing system. A clockwise motion increases the pressure, and finally it will close the valve. The APL valve is part of the flow path when it is in the bag mode. If the provider gives a breath by squeezing the bag, and the breath exceeds the pressure of the APL valve, the valve will open and allow the excess gas to escape to the scavenging system. This acts as a safety device for the patient's lungs. During inspiration, the valve is closed, while during expiration it will open when the set pressure is exceeded. During spontaneous ventilation, it can be partially closed to give positive end expiratory pressure, PEEP. In manual ventilation, the valve must be semi-closed for enough pressure to generate to inflate the lungs. It is very important to keep a close vigilance on the bag, especially during manual, spontaneous breathing. By looking at the bag, the provider can tell if the patient is breathing. The bag can collapse or overextend. Bellows can either be ascending or descending. If the bellows ascend during expiration, they are ascending. If they descend during expiration, the bellows are descending. Most of the newer ventilators are ascending because they are safer. With the ascending bellows, they will not ascend if there is a disconnection. This serves as a visual alarm. The scavenging system will remove waste anesthetic gases from the room. The waste gases are vented through the APL. The system at KUMC is an active scavenging system which is connected to the hospital's vacuum system. The canisters that hold the carbon dioxide absorbent have a screen on the bottom that allows for drainage and flow of gases. There is a lever to raise and lower the canisters, and an upper gasket to assure a tight seal. Water is formed from the hydrogen and hydrogen ions. This chemical reaction creates heat that can be felt by touching the canisters. Channeling of gas through the granules can decrease the efficacy of the absorbent, and it can make it hard for the provider to see the color change. The pH indicator, ethyl violet, is added to soda lime to help estimate the effectiveness of the absorbent. Ethyl violet has no color until the pH of the absorbent decreases. The absorbent will become exhausted and will then turn violet. Regeneration of the soda lime can occur when not in use because it becomes colorless again. However, the ability to absorb CO2 will be low and it will return to the exhausted color purple quickly. Be aware that there are different colored pH indicators. The canisters can either be filled with loose absorbent or they might be pre-filled. If they are pre-filled, there is a plastic wrap covering it that must be removed. Soda lime is granules and 4 to 8 mesh. Mesh size is the number of openings per linear inch in a sieve through which the particles can pass. As particle size decreases, resistance increases. Also, the smaller the granule size, the more surface area is available for absorption. The common gas outlet supplies gas to the breathing circuit. It is sometimes called the fresh gas outlet because it adds new gas at a set and known composition to the circle system. There is an auxiliary common gas outlet on some machines. The auxiliary common gas outlet is used for the low-pressure circuit leak test. The oxygen flush valve interacts between the high-pressure and low-pressure circuit. It is closed unless the operator opens it. It will deliver 100% oxygen at a rate of 35 to 73 liters per minute directly to the common gas outlet to the circuit. The oxygen flush valve has some risks. Barotrauma can be caused if the valve is flushed during the inspiration phase of positive pressure ventilation or if the valve sticks in the fully open position. Using the valve can cause awareness since the oxygen flow dilutes the anesthetic and does not flow through the vaporizer. This concludes the breathing system of the anesthesia machine. There are other parts that are hidden that we did not go over. Here at KUMC, if there are problems with the anesthesia machine, there is a team that knows the machine very well. But if they are not available, just remember that on the breathing system, it can come apart without any tools and be put back together as long as all the seals are lined up correctly.